So with that said, let me get into this. Today we are going to talk about what is called as standard deviation. Okay, in the standard deviation, we wanted to calculate the standard deviation for population data, sample data, standard deviation in Excel, and why calculate standard deviation, all that. So if you're excited about today's session, type XITD in the chat box and let me open the amazing session, chapter 5, okay, of this session. Okay, this is going to be very interesting. Excited? Good, good, good. I want a lot of excitement in the chat box so that, good, ready to go. Okay, do you see chapter 5 on the screens? Type C5 in the chat box. Okay, if you see chapter 5 in the chat box, okay. Good, thank you very much. Okay, Atul alone doesn't see. Okay, so we will talk about Pareto, standard deviation, Pareto principle, voice of the customer, and basic metrics. Okay, now this all forms the basic Six Sigma concepts. Okay, let's get into standard deviation. In statistics, standard deviation is a measure of the amount of variation of random variables expected to be about its mean. Okay, how many of you know about standard deviation? Type KNOW. If you don't know, type NO in the chat box. If you know, you type KNOW. Ideal lesson, you are still typing to host and panelists. Please change it to everyone and type your message so that everyone can see your message. Okay. Okay. Now there are a few people who don't know. Okay. Now I will pause the okay, I'll pause the chat for some time. Sorry, I'll pause the screen sharing for some time and I will explain in a layman's language. Okay, I'll stop sharing the screen for some time. I will explain in layman language. Okay, layman language. All of you type LML in the chat box if you want to know the layman language of knowing what is standard deviation. Good. Good. Okay. Now, everywhere there is always a deviation in life. Nothing is constant. There is always a variation. How many of you agree? You type agree. And how many of you super agree? Type SA in the chat box. There is always a variation in everything. The variation could be small. The variation could be large or somewhere in between. But there is always a variation. That is why variation cannot be eliminated. Variation can be only reduced. And the more and more you reduce the variation, you build the capability because it is more predictable. It is more stable if you reduce variations. It is more predictable. It is more capable. Okay. Okay. Now what I'll do here is, if you want to understand the standard deviation, assume that if you see the class of people, not all the people will be of the same height. At least there will be a few millimeters difference between each and every person. So the average deviations of each of these people, okay, there is something called as an average of all the height. Okay, what is the average distance from this average? Okay, everybody is distancing with a distance. Okay, like for example, somebody is 165 centimeters, the other is 164. So there is a 1 centimeter. Somebody is 159. So there is a 6 centimeter. And so the difference between the average and that particular point, there is a value and there is an average of that. How many of you understood it on a scale of 1 to 10? Please give me a 9 or 10 if you understood it. I'm coming to the very, very basic concept of good. If you have understood this, now I will explain you a different example. Assume that there is a big circle and I'm standing in the center of the circle. Assume that there is a big circle. I'm standing in the center of it. I have handful of marbles. I have handful of marbles. I drop all the marbles exactly in the center of the circle. And what happens to those marbles? If I drop, let's say I have a funnel at the center, and then I open up the funnel, all the marbles drop at the center of the circle, which is on the floor. What happens to these marbles? What happens to these marbles? It will spread, it will fall down, it will scatter. In which direction it will disperse? In which direction will it disperse? In which direction will it scatter? That's the question. In which direction will it disperse? In which direction it will? In all directions. It will go in all directions. All this. Okay, fine. Very good. Okay, now what I'm saying is, somebody asked for certification. I will explain about the certification in the upcoming webinar. That's why I put the link also. Okay, I'm not going to talk about certification now. I'll talk about it in the end. But if you quickly want to know it, you can register the upcoming webinar. Now, please, let's focus on this. Now, you see there is a center point. A marble can be, one marble could be away from the center, there is a distance. The other marble could be in the other direction, there is a distance. The other marble could be other distance. So each marble is away from the center by a particular measurement, either in centimeters or meters. How many of you are clear about it? Type CC if you're crystal clear about this. Now I'll take the next step. Imagine that you find out the average of all this. That is the average deviation from the center. How many of you understood this? Type US understood in the chat. This is, and now since something can be positive, something can be negative. Okay, if it is 165 is the average height, somebody could be 170, that is positive 5. Somebody could be 160, that is negative 5. But the distance, the deviation is the same. Okay, one is positive 5, one is negative 5. And because of this positive and negative 5, there is something called as root mean square. All of you type RMS in the chat box. And this is where people get scared about. RMS, root mean square. Which means you find out the difference. If it is, the difference is 5, the square of 5 is 25. If the difference is minus 5, again the square of 5 minus 5 is also 25. And again square root it will come to the deviation of 5. Okay, if it is clear on a scale of 1 to 10, please give me 9 or 10 if it is super clear. And this concept they use. Now I can type the formula. I can enter into the session. Okay, great. Okay, thank you very much. Now, let me share the screen now. Now, the standard deviation, the main goal of Six Sigma is to reduce the defects. The main goal of Six Sigma is to reduce the defects. And if you reduce the defects, the return on investment will go up. By reducing defects, the team increase productivity, decrease overall cost, increase the customer satisfaction, and create maximum profit. If you agree with me on a scale of 1 to 10, please give me a 9 or 10 if you agree with all this. Okay, because variation disrupts the flow. Variation causes instability, and variation makes you incapable. Okay, super. And that is why we needed to find out what variation is. In order to find out what the variation is, there is the best way that statistician is given, and that is called a standard deviation. All of you can type SD or sigma in the chat box. And that is where we are talking about Six Sigma here. Okay, one standard deviation is called sigma, SD or sigma. This is the root of, is a fundamental to this whole Six Sigma methodology. This is what sigma is. Awesome, awesome, awesome. Okay. Now, one idea inherent in the Six Sigma methodology is that variation is a root cause of many defects. Okay, that is the whole inherent of this Six Sigma methodology. Now we find out there are two things in statistics. One is called as a central tendency. Okay, and the other thing is called as the spread. Okay, all of you type CT, central tendency, in the chat box. Central tendency. Any data has a central tendency, and it has any data has got a spread. Okay, the central tendency. Okay, be with me. Okay, be with me. The central tendency, there are three measures of central tendency: mean, median, and mode. All of you type M in the chat box. Mean, median, and mode. Okay, let me quickly explain to you mean. Mean is equal to average. Somebody put it in the chat box. Mean is equal to average. When I ask in the interview, okay, what is the difference between mean and average? The answer should be both are same. Some people will start explaining the difference between mean and average. Okay, mean and average both are same. Okay, all right. The mode is the maximum occurring value. The median is arranging the data in ascending order or descending order and finding out the middle value. That is median. Okay, mode means you pick up what is the maximum occurring value, and that we call as a mode. I'll give you an example, don't worry. Okay, now this is the data set. Okay, in this data set, how many numbers do you see in the data? How many numbers do you see in this data? 6 numbers are there. Okay, fine. Now let us calculate which is the mode in this data. Mode alone, maximum occurring value. Which is the maximum occurring value in this? 7. Correct? So that is called as mode. Mode is clear. Okay. Now, if you arrange the data in the ascending order or descending order, which is the middle value? Okay, now the data set is actually 6 values. So the middle value is central 2 values. Okay, which is the center 2 values? If you arrange 1, 3, 4, 6, 7, 7. There are 2 numbers in the center. Okay, 1, 3, 4, 6, 7, 7. So 4 and 6. Okay, 4 and 6. So what is the average of 4 and 6? Okay, it is 5. Okay, you can call median as 5. Average you know to calculate. Okay, now having said this, so summing up and adding all the values and dividing by the total number is called as a mean, and most common value is a mode, which you have seen, and median is 6 plus 4 by 2. Okay, 6 plus 4 by 2. If this is clear on a scale of 1 to 10, please give me a 9 or 10 if it is super clear. This is called central tendency of data. Central tendency of data. So far, if you're finding it interesting, useful, valuable, fantastic, awesome, put it in the chat box. Give me a dose of dopamine. Give me that encouragement. Let me proceed with the session today. I'm going into this depth because many people said they don't even know what is standard deviation. And that's why I wanted to go into this depth. Okay. Thank you very much, each and every one of you. Let me go into the depth of this. Okay. And if you people who are looking for certifications and stuff like that, I'm not going to sell any certification here. Okay. So just join this upcoming webinar and I'll tell you exactly what all levels of certification you can upgrade to if you're interested. Only for interested people can come to my upcoming webinar. Okay. Now, your friend is coming with this. What do you see on the screen? And how many of you like this? How many of you like this? Okay, I'm asking, somebody, when I showed this picture, somebody asked, how many of you like this? You're asking the lady or the cookies? Give me a smiley heart. Let's have some fun today. Okay, what do you like, the lady or the cookies? Somebody said, I want both. Okay, are you all having fun? Whoever is having fun, type FUN in the chat box. And that's a way to learn Lean Six Sigma, okay? Not with boring stuff of statistics, formula, and other things. I'll come with fun, okay? Good. Thank you very much. And you will have a lot of fun. Join my upcoming webinar also and be a part of our Inner Circle community. If you join my upcoming webinar, you'll be a part of the Inner Circle Elite community, okay? Okay, fine. Let's go into the depth. Okay, so this girl, what is she does? She does this. When oven consistently reaches and maintains the precise temperature of 350 degrees for 5 minutes. So the temperature is 350 degrees and the time is 5 minutes. The risk of burning the cookies decreases. Okay, the risk of burning the cookies decreases. So the temperature required is 350 degrees for 5 minutes. Similarly, meticulous measurement of the ingredients by a cook enhances the likelihood of consistent, delicious cookies. Okay. However, introducing variations in the process compromises this consistency and leading to potential defects. Okay. If the temperature is not maintained consistently or the time is not maintained consistently, this is called variation, inconsistency, instability. Okay, variations, and that will lead to the cookies either underbaked or deep fried. So far, if it is clear, type SC, super clear in the chat box. Now I'll go into a little bit of depth. Good. All right. Thank you very much. Now, be with me. This will go a little deeper. Okay. Now, this cookies, for instance, if the oven fails to sustain the exact temperature, the cookie is burned. And if the cook inaccurately measures the ingredients, the sweetness of the cookie might be compromised. Okay. Now, such variations result in inconsistent quality. So variation results in inconsistent quality. There are factors that contribute to that inconsistency. Each factor can be at a different level. We will explain factors and level as we go deeper. Okay. Now, for example, temperature is a factor and the levels are 350 degrees and 370 degrees. There can be multiple levels. The time is a factor, say 5 minutes or 7 minutes. Sugar is a factor, maybe 1 teaspoon or 2 teaspoon. If factors and level you have understood, type FL understood in the chat box. Factors and levels. And each of these factors at different levels of combination will produce a different output. And hence it is important to measure. You should find out which are the factors, which are levels, and maintain the consistency, which is called reducing variations. Okay, fine. Imagine if you cook consistently. If the cook consistently set the oven at 400 degrees and consistently uses half a cup of sugar for every batch. In this scenario, both the process and the outcomes lack variation, resulting in perpetually bland and burnt cookies. Okay. Okay, if the oven is set to 400 degrees and uses half cup of sugar every batch. Now, if you see here, there is a central line, there is a variation. If you see here on the right hand side, where is the variation more, left side or right side? LHS or RHS? Where is the variation more? LHS or RHS? Naturally, right hand side, the variation is more, right? Excellent. Okay, now be with me, don't miss the bus. This is A and B and less deviation, this is more deviation. And now this deviation is a word that we are using. Okay, instead of variation, we use the word deviation. And when you take the average of all this deviation through a statistical approach, which is like, calculating the average finding out how much is each data point from the average, squaring it, square rooting it with the formula. This is called standard deviation. Okay. Now, the formula for standard deviation. I don't want any of you to run away after seeing this formula. Okay. All of you type. How many of you will stay type WS in the chat box if you will stay after the screen? How many of you will have the guts to stay after this? Will stay? All right, let's see. How many of you will stay? Don't run away after this formula, okay? Now, if you see here, most of the data are centered here. Suppose even if you see the weight, if people around 40 years, let's say, they are 70 kgs in weight, and some of them might be underweight, some of them can be overweight, okay? And the height also. Average height may be 165, some of them might be under height, some of them might be over height, okay? Now, the formula for this is, the variation is, X bar is the average, and what is the deviation for each and every point? Okay, in statistics, it is written like this. Forget about sigma varying from 1 to n and the thing. All we need to do is each and every point, you need to find out its distance from the center, its difference from the center, square it, divided by the total number of data points like that, add it, divided by, and then square root it. Okay. Now let's take an example and do it, because with this formula, you'll get scared. That's why I said don't run away. And only one person has run away. Okay. I'll find out who is that person who has run away. Okay. Now, if this is the formula, okay. Now, I'm not going to the depth of why it is n-1, because for the population and sample, I will explain later. For the sample, it will be n-1. We will discuss it later. Okay. This is the formula. And this distribution is called as a normal distribution and normal distribution curve, where statistically it is proved that if you have plus or minus 1 standard deviation, it is applicable for any normal distribution. If you collect the data, calculate the standard deviation, you will find 68% of the data within 1 standard deviation, plus or minus 1 standard deviation. You will find 95% of the data within plus or minus 2 standard deviation. And you will find 99% of the data within plus or minus 3 standard deviation. So the important is you calculate the standard deviation and you can be sure that 68% would be between plus or minus 1 standard deviation, 95% plus or minus 2 standard deviation, and 99.7% plus or minus 3 standard deviation. How many of you understood this on a scale of 1 to 9? Give me a 9 or 10 if this understanding is clear. And that is why we calculate standard deviation. Super. Very good. Most of you have typed 9 or 10. Great. Okay. Okay. Now, let's look at this. So for the population sample, the formula slightly differs. For population, it is an infinite amount of data. So large amount of data. So we have n here. This is small amount of data. We have n-1 here. And there is something called degrees of freedom, which we'll explain later. But as of now, remember this formula. Okay. We'll do a small exercise here. Okay. Yeah. Population variation, sample variation. And variation is nothing but the square of standard deviation. Okay. Square root of standard deviation is called as sigma, as simple as that. Okay. So now let us say, we'll take an example. Okay. For our explanation, we will use a data set of a teacher. She wants to find the standard deviation of scores on the latest test. The scores from our class of 15 students are this. Okay. So this is the data point of the score, let's say mathematics score for 15 students. If this is clear, type super clear SC in the chat box. We'll go slowly and steadily to calculate standard deviation. Okay. Okay. So this is the score of 15 students. Okay. Next step. First step is calculating mean. Okay. What is mean, which is mu, is an average. How many of you know to calculate average? Type KNOW here. If you don't know, type NO here. How many of you know to calculate the standard deviation? Okay. So you know the mean. The first step is clear. Okay. The first step is clear. So here it is, you are adding everything and dividing by the total number, which is 15, and you get 1 to, so total you get 1278, and then you divide that with 15, okay, you will get this 85 point, this thing. There is some, this thing here, we'll calculate it, no worry. There is some, seems to be some 1278 and 1193, we'll correct it. Okay, whatever it is, add everything and divide it by 15. Okay. Now, the second one is, the second step is subtract the mean and square it. Okay, first number is 67. So the average we saw is 85 point. What is the average we saw in the last slide? Anybody remembers it? 85.2. So 85.2 is average. So subtract and then square it. Okay, minus 18 point and minus 18 point. How many of you are clear with step 2? Type yes to C. Step 2 clear. Yes to C if the step 2 is clear. Madhavi Singh, very good. How many of you are clear? Step 2 is clear? Okay, fine. Okay. Preeti Mishra also, step 2 is clear. Okay. Now, once you do this, you apply to all 15 numbers that you end up with the list of these results. Okay. Same thing you do for all 15 numbers. If this is clear, type super clear, SC in the chat box if this is clear, super clear. Good. Okay. Now, great. Now, once you do this, the next step is the third step. Okay. The third step is finding the mean of the results. What is the mean of the results? You put all of that, the sum of all the above numbers is 14.6 and then divided by 15, which is 99.76. If step 3 is clear, type S3C in the chat box. If step 3 is clear. Good. Now that step 3 is clear. Okay. This is called as variance. Okay. All of you type V in the chat box if the variance is clear. This is called variance. This is called as a variance. In 3 steps, we have calculated the variance. And then finally, the square root of variance is called as a standard deviation, which is sigma. Okay. All of you put the Greek letter sigma if you have the sigma on the emojis, if you can find sigma. Anybody can find the emoji sigma in the chat box? You can send it here. If you can, I don't know, I have not found out sigma here. Let me search for sigma. I'm not finding sigma. I don't know if you guys can find out sigma here. Mu, you find out. Somebody has found out mu. Oh, that's fine. Interesting. Santosh, same thing. You can find out sigma also if you find mu. Okay, great. All right. Okay, now that we have calculated sigma, this is called a standard deviation of the test score is 9.98. Okay, now you can see for yourself. See, what do you see on the screen? What do you see on the screen? Okay, before I put this, I'm asking this. What do you see on the screen? Gems or germs? Cartoon figures, okay. Right. Okay, no issues. Here, the lab technician measuring the response of bacteria, okay, to an ingredient in a potential treatment. They want to know how long it takes bacteria to respond. Some data response in minutes is this. Some response in 2 minutes, some response in 3.5 minutes, and some response in 4 minutes. So calculate the standard deviation. The key formula is S is equal to this X bar First calculate the average, then summation, then square and n. Okay, this is the exercise for you. Okay, so if you want to use the Excel sheet, you can quickly put STDEV, but you can also use ChatGPT, type all these numbers in, calculate the standard deviation. So if you see the standard deviation using the Excel, you can type this and you will find that the standard deviation is 0.71. So the formula is STDEV of that particular thing. If this is clear on a scale of 1 to 10, please give me a 9 or 10. If Excel is clear, the same numbers you can put it in ChatGPT. If you are wanting to use AI, just copy the numbers and ask, please calculate the standard deviation of these numbers. Okay, the ChatGPT will give you the standard. You don't even need to use Excel formulas. Remember Excel formulas anymore. Okay, great. Now that's what I'm going to teach in my certification programs, all AI based. You need not have to use costly AI softwares. Okay. Sorry, costly softwares like Minitab or any other earlier softwares. All that could be done in ChatGPT. Okay, all the data analysis can be done with, and exactly, in fact, I can call it as AI LSS, AI Lean Six Sigma. Okay, ILIS. So the formula executes this sample. Okay. Now, why calculate the standard deviation? We want to calculate the standard deviation because standard deviation provides an insight into variability of the process. Okay. So you can also see that, indicates that most of the process deviates from the center like that. The information informs the teacher about the range of performance. Okay. So if you see that the average scores of 90 with a standard deviation of 3 suggests that students are likely learning and retaining the material as expected. Conversely, the average of 64 with a standard deviation of 2 might indicate issues with knowledge and retention or the test structure. If this is clear, type CC, crystal clear in the chat box. This is how we use the standard deviation. Okay. Now, these scenarios highlight the significance of variation of the student's performance. Okay, wider the standard deviation, then greater is the discrepancy in the students, and this prompts the teachers to investigate further. Okay, the standard deviation not only directs attention, but it also plays a crucial role in statistical analysis. This is the foundational concept of the statistical process control. All of you type SPC in the chat box. This is the foundation. All of you type. Oh, found Sigma? Michelle Joshi, fantastic. Okay, nice. This is the foundation of. So how many of you are ready for Q&A? Type ready in the chat box. We'll have few Q&A, okay? Okay, before that, if you want, somebody asked for the previous slide presentation and other things. What I suggest is I will share this presentation inside this Lean Champions group, and I'll share these videos inside this. Okay, so if you want to have this, just join this group and I'll post the presentation there. Okay. And of course, if you're looking for certification, you can always come to my upcoming webinar. Okay, having said that, let me quickly get into the question and answer for today. Okay, the question: what is the formula for calculating the variance of a data set? Okay, standard deviation by mean, sum of square standard deviation by number of data points in the set. Okay, mean by standard deviation, mean into standard deviation. What is the formula for calculating variance in the data set? All right, B is the correct answer because we said xi minus x bar the whole squared divided by the number of data points. Okay, that is the sum of squared difference. This is called root mean square. Okay, when you square root it, it becomes a standard deviation. But then this is variance. All right, so this is how it is, the formula. This is a variance formula. If it is clear, type SC, super clear in the chat box, because at the end of standard deviation, you should fundamentally know this. Okay, thank you very much for your active participation. Now, the next one. Question. Which of the following statements about standard deviation is correct? Okay. It measures the dispersion or the spread of all the data points around the mean. It measures the central tendency of the data set. It is always equivalent to mean, and it calculates all the data points. It is calculated by all data points. Okay, let's see the answers quickly. All right, so it measures the dispersion and the spread. That's the right answer. Whoever has typed A, congratulations. And question. If the standard deviation of the data set is 0, what does it imply? All the data points are equal to target value. There is no variability in the data set. Data is incomplete or data is perfectly normal. There is no variability in data set, okay? It's not equal to target value. Target value can be something else, okay? There is no variation. All right. Okay, hold on. If the data set, if the data point is significantly higher than the mean, if the data point is significantly higher than mean, how will it affect the standard deviation? The data point is, will it increase, decrease? What will happen? Decrease, increase, no effect, make the data set in. Of course, it will increase the standard deviation, okay? Okay, I think this is the last question. What is the range of possible values for standard deviation? Any positive real number, only integers, only prime numbers, only even numbers. Of course, any positive real number. Okay. So, if you found today's session interesting, useful, fantastic, just put it in the chat box.